Hello and welcome to This Week in Engineering.
Brought to you by engineering.com.
SpaceX docks with ISS. For the first time ever, this week, a civilian spacecraft docked with the International Space Station. The SpaceX Dragon capsule was grabbed by the space station's robotic arm and plugged into a docking hatch. In 2 weeks, the capsule will attempt re-entry and an Apollo-like ocean splashdown and recovery. I say, let's put the commercial into commercial spaceflight. This ignition is brought to you by Bud Light, the docking by Dockers, and the splashdown by Wet n Wild Water Parks. Also, it's not a Dragon capsule, it's a Gecko capsule.
Robot builds tools with a glue gun. Roboticists at ETH Zurich have built a robot that can make its own tools using a hot glue gun as a sort of low-resolution 3D printer. For the challenge of moving water from one container to another, the robot first builds a cup by laying down one layer of hot melt adhesive at a time, then builds a handle for the cup, attaches it, and finally uses the cup to complete the challenge. Robots with hot glue guns? I knew it was coming. Asimov's little-known fourth law of robotics is make your own Hello Kitty resin charms.
Laser weed killer. Researchers from Leibniz University in Hanover, Germany have developed a system of chemical-free agricultural weed control using automated lasers. The system includes cameras to monitor the ground and software that can recognize many types of weeds. The lasers have to be strong enough to kill the weeds, or else the weeds can use the energy to grow. The system currently patrols 1 square meter of greenhouse, but should soon scale up to larger areas by moving on rails. For most weeds, sure, lasers are great, but for ragweed, the mother of all allergens? No, burning's too good for them.
Bionic Snail. Researchers from Clarkson University in New York and Ben Gurion University of the Negev in Israel have implanted enzyme-coated electrodes into the body of a snail, generating small amounts of electrical power without harming the snail, essentially creating a completely sustainable biological fuel cell. When the snail's glucose level went down, so did the power generation, but it increased again after the snail rested or ate. The snail generated a few microwatts at about half a volt and provided power for months. This is the kind of bionics I don't fear, because if bionic snails turn evil, the worst they can do is wreck my garden and leave my fish tank unclean.
Blanket produces biochar. Sawmills and paper mills tend to create piles of unusable wood, known as slash piles, which are often either left to decay or are burned, but either way, it releases CO2. Now, students from the University of Washington have developed a pyrolysis blanket that covers a wood pile, insulating it and preventing airflow. The wood is burned underneath, but without access to oxygen, the wood becomes biochar, which can be used as fuel or for agriculture. The students have formed startup carbon cultures to develop the blanket. I prefer piles of dead wood for their original purpose, to warn others not to go into the real pet cemetery.
Robot climbs cloth. Roboticists from the Chinese Academy of Sciences have created Clothbot, a robot designed to climb up pieces of clothing by creating a wrinkle which it grips with wheels that spin as it climbs. The Clothbot is a very light 140 grams and has an omnidirectional tail that adjusts its center of gravity. I'm used to robots taking jobs, but now they're taking the jobs of... aerial dancers? Okay, well, I'm okay with that. Well, that's it for This Week in Engineering. For more information about these stories, check out the links in the description section.
If you like what you saw, let us know by leaving a comment, giving a rating, or clicking a like button. Also, tell your friends. All right, engineers, let's get back to work.